Welcome to the introduction to client and server basics. In this video, we'll introduce the concept of the client and the server in a way that's easy to follow and understand as possible. An understanding of client and server scripting in MapleStory Worlds is critical for multiplayer development, so if you've always wanted to make a multiplayer game and didn't know where to start, you've come to the right place. Let's imagine that we've got two players or users, each with their own client. Client here refers to the device that the player is connecting to MapleStory Worlds on, and this can be a desktop PC, a laptop, or a mobile device. Each client, Client A and Client B, communicates with the server and depends on the server for updates on what the other users are doing. Each client doesn't know what the others are doing, so the clients let the server know, I use a skill or click the button, and the server is responsible for listening in on those client updates and communicating that to all the other clients. For example, user A wants to use a skill and presses the button to activate it. The client lets the server know, hey, I want to activate a skill, and the server will verify and process this request and let all the other clients know, user A has just activated the skill, and here's all the info that you need to activate it. This way, all clients, not just the client that activated the skill, will activate and perform the skill, thus synchronizing user A's action with all the other clients. Now you might ask, what's the purpose then of the server? Why can't users just communicate directly with each other? To answer this, let's imagine we've got 4 users this time, users A through D. Everything that lives on the client is susceptible to hacks and can be changed by the user. So if the user decides to activate a method in your code that gives them unlimited experience points, that information is communicated directly to the other clients, and there's no way to know what the real source of truth is. So generally, all critical information is stored and processed by the server, with the clients requesting inputs to be processed based on the server's truth. This way, all clients will stay properly synchronized and we keep our game fair for everyone. Here, we can see that our data is managed by the server instead. The client simply makes the request and the server processes the action and updates all the other clients with the result so that it can be synchronized. For data reliability as well as security, this is the more preferred approach for client-server development. Rather than having the clients dictate and manipulate critical data such as player experience, the information is stored and managed by the server, with the client simply requesting that data or requesting actions to be performed that depend on that data. So we mentioned that data should be managed from the server side. Well, what does this actually look like? As you know, MapleStory Worlds operates based on entities, components, and logic scripts. Logic scripts are globally accessible scripts that are not associated with any one entity, but components are attached and owned by that specific entity itself. So let's imagine in this scenario that user A and user B both have entities that share the same component, and that component has one property, property A, and one method, method A. Even though they both share the same component, they each have their own versions of their respective components with their own values. So if user A wants to modify property A, is the property modified on the client? Or is it modified on the server? How do we decide that? This is where synchronization comes into play. Property synchronization in MapleStory Worlds has 2 main modes, sync and none. If a property is marked as sync, it means that whenever a property is modified from the server, it automatically syncs the value with all the other clients. Sync might be used for things like player HP or EXP, level values, where you need a given player's value to be synchronized across all the other clients. If you didn't want to automatically synchronize the value between the client and the server and wanted to keep the value strictly client-side or server-side, or maybe even have different versions of both so you can manually synchronize the values to your own timing, you can utilize the none type. This will ensure that no automatic synchronization occurs, and the client or server manage their own versions of that property. This might be useful for items or data that you need to ensure stays only on the client or the server, such as a volume setting on the client or quest progress on the server. Note that for sync, I mentioned server and not the client. The synchronization happens only from the server to the client and not the other way around, meaning that if the value is modified from the client, the server will not be made aware of this change, causing a desync between the client and the server. This again is to ensure that the server remains the main source of truth for synchronization tasks between the server and the clients. Here's what that sync tag looks like in the MapleStory Worlds Maker engine for both synced and non-synced properties. Let's return to the example with our friends user A and user B. If both users' player entities share the same component, and that component has a property named property A, If property A was a synced property and was modified on the server, that value will be populated for all clients' version of property A on user A's entity. User B's entity will remain unchanged for the server and the clients because even though they share the same component, they're still managed separately. So I mentioned that there's two types of synchronization tags. Well, actually I lied. There's a third one called target user sync. This acts very similarly to the sync property, but this is more of an optimization step to save on network bandwidth. Whenever a sync property is modified on the server, it will populate to all the other clients. However, with the target user sync property, it will only update for the client who owns the server property that was modified. So for example, here's the sync behavior as we understand it now. Player entity A has a property named Meso, and so does player entity B. Both are separately managed as we learned. When the Meso value for player entity A is changed on the server, all clients A and B will be notified of that update. However, with target user sync, when player entity A's Meso value is changed on the server, only client A, as the owner of player entity A, will be notified of that change. The other clients will not be notified of that change. So this is useful for things like a meso count, as we use in this example, because we want to make sure that that meso count is managed securely on the server, but only my client needs to know what my meso count is, and the other clients don't necessarily need to know what my meso value is. Synchronization behavior for both sync and target user sync are available for most property types in MapleStory Worlds Lua, but certain types don't support syncing, namely the AnyType and the table type. So if you need to sync these types between the client and the server, it will need to be done manually. So feel free to pause this video to review this chart in more detail. We talked so far about property syncing and what happens when a property is changed. But what about methods? What happens when we call a method? Is it called from the client or from the server, and how do we control that? Functions also can exist separately for the client and the server, and you can designate a method to exist either on the server or the client, and when called by different execution spaces, such as a client method from the server or a server method from the client, the execution of the method will be delegated to its owner's execution space as a remote procedure call. In this example here, we've designated method A to be owned by the server, method B to be owned by the client, and method C to be owned by the server. Let's say in this scenario, method A calls B and B calls C. Because method B is a client method, when server method A calls client method B, the server delegates the execution of method B to the client, creating network traffic as the server communicates with the client. Similarly, when client method B calls server method C, network traffic is created in the same way as the client communicates with the server. So it's important to be mindful of which methods you're calling and what execution spaces you're calling them from, as calling methods across different execution spaces generates network traffic. This is a chart of all the different types of execution spaces possible to be assigned to methods. It may seem like a lot to take in, but it's actually not as complex as it looks. We've already learned about two types of execution space tags, the server and the client. This simply defines where the method resides, whether that be on the client or the server, and when called across execution spaces, the method execution will be delegated to the execution space of the owner. The only suffix simply restricts execution across execution spaces, meaning the client will not be able to call server-only methods, and the server won't be able to call client-only methods. Usually, this is intended for security and data reliability purposes. Multicast is owned by the server, but is executed on both. What this essentially means is that whenever the multicast method is called on the server, it will be called once on the server, then again on the client. And finally, we have none, which designates that this method is owned by both the client and the server and will hold a copy for both execution spaces. When a none method is called, it will inherit the execution space of its caller and be executed on the same execution space, meaning that if the server calls a none method, the none method will be called from the server execution space, and vice versa. When a none method is called by the client, it will be called from the client execution space. Here's a visual diagram representing all the relationships we've taken a look at so far. Feel free to pause this video and process all the relationships here. Let's now switch over to the maker and see all of this in practice. We'll begin with a simple example. We'll have two properties, HP and master volume, and we'll see what happens when we modify this value on the server. The goal here is to ensure that when we modify the value from the server, the client will also be updated of this change. So let's get right to it. So here we are in Maker, and we've just got a basic scene here. And let's start by creating a new component, and let's name this player info. And let's attach this player info to our default player. And let's double click to open this up. And here, let's create two properties. We'll have the first one not synced, and we'll have the second one synced. And we'll name this first one master volume. And let's create this out of 100% volume. And then second one, let's name this HP. And let's say our player starts with 10 HP. So here we have one synced property, our HP value, and we have one non-synced property, our master volume. Let's head back into our scene, and we'll make sure that we have our server hierarchy window here. And this is going to allow us to visualize the entities that are on the server side. So our hierarchy is going to be everything on our client. Our server hierarchy is going to be everything on our server side. So let's press play. And here we've got our client side user. We've got our master volume with 100, and we've got our HP at 10. We check our server side, and we've also got our player info with our master volume at 100 and HP at 10. So remember that we have our master volume that is not synced, and we have our HP that is synced. So let's say that we increase this to 20. So we've increased our HP, we got a health potion, and we've increased our value to 20. On our server side, it is now at 20. If we check our client side, our client has also updated to 20. So on the server side, we've decreased the volume to 90, but on our client side, the volume is still at 100. And the reason for this is because our master volume is not synced and our HP value is synced. Now, if we go back to our client and let's say that we reduce this HP, we took 5 damage and now we're at 15. If we change this from the client and we check the server, so client's at 15, server is still at 20. And again, the reason for that is because synced properties are synchronized from the server down to the client, not vice versa. So modifying this HP value from the client side will not affect the server value of our HP. And by doing this, we ensure that important values that need to be tracked and stored securely, like our HP value or our EXP value and things like that, are managed and modified by the server and not by the client. So the server will not accept this change as a valid change because it came from the client. The server should be the one modifying this value so that it can update that to the client as well. Next up, let's try adding a method here, and we'll use one of our default methods on begin play, and we're going to keep this as server only. We have, of course, the option to change this to client only or not used, but for now, we're going to keep this as server only so that we execute this from the server side. So here, let's increment our value for HP, and let's reduce the master volume by 10 here. So we've done what we did in the inspector, but this time we just do it in code. And this should do exactly the same thing that we've done. Let's log this just to double check that this is indeed executing from the server side. So let's create a quick log here. And if we press play, we get that confirmation that on the server side, we executed. And we also get the entity that sent this log. And if we check our server side, we have our master volume at 90 because we decremented that. We've got our HP at 20 because we incremented that. On our client side, we have our HP at 20, but our master volume remains at 100 because our master volume is not synced. So we've incremented this value from the server and decremented the master volume by 10 on the server, but the HP is reflected because it is synced, and the master volume is not because it is not synced. Now let's try modifying this so that instead of the server, it is executing from the client side. So we should expect the same thing, right? Our HP should be at 20 and our master volume should be at 90. So checking here, our server has not updated any of the values because we had incremented this from the client side. Master volume will not be synced either way because it is not a synced property, but our HP value is not synced because we had modified this from the client side. So we can see those values reflected on the client, but it is not reflected on the server. Finally, let's change the execution space to not use and see what happens. We should expect the same thing here because if we remember, not use executes the default event methods, both on the server as well as on the client. So this should just increment our HP by 20 for the client and the server, and it should decrement our volume by 10 for the client and the server. Pressing play, we can see that we have executions on the server and an execution on the client. And if we check the value, we have 90 and 20 on the server, and on the client, we have 90 and 20. So everything seems to be working properly. Well, let's do one more thing here. So we have the ability to distinguish whether or not this method is being executed from the client or if it's being executed from the server. And this is important, especially for not use properties where it can be executed from either. So here we're going to use self is client or is server. So these are the Boolean methods that will allow us to check if this is the client or if this is server. So we want to check for the client. And we're going to do if we're the client, then we will wait 1 second. So if we're the client side, we're going to wait 1 second before we execute this. And let's move this to after so that we know exactly the moment that this is incremented. And let's press play and see what happens. So we've got execution from the server and we've got an execution from the client. Now, if we check here, we've got what we expect on the server side. We've got 90 and we've got 20. And we should expect the same thing from the client side, right? Well, if we check here on the client side, we've got 90, but for the HP, we've got 30. Now, what's happening here? Why did we increment twice? Well, the reason for that, we'll actually utilize another default method called OnSyncProperty to visualize what's happening here. Let's keep all of this the same, but the OnSyncProperty will allow us to detect the moment that a server-side property is synchronized to the client. So we'll check if the name value, which is going to be the name of the property, is HP. Then we're going to log value updated. And let's press play and let's see what's actually happening here. So we've got an interesting order of execution here. So first we've got our server that executed, and when the server executed, we incremented our HP value by 10, and we've decremented our master volume value by 10. So on the server side, we've got the correct values. We've got 90 and we've got 20. But because our HP value is a synced property, this value, which has now been incremented to 20, has been updated to the client. So value updated ensured that our property was sent to the client and synchronized as 20 prior to the HP value then again being incremented to 30 on the client side. Because master volume was never synced, this value stayed at 100 and was decremented by 10 to 90. But our HP value was at 20 because it was synchronized to 20 from the server and was incremented to 30 at the time of execution. So this goes to show that it's very important, and this is a common mistake that is made when it comes to client and server programming, is with this kind of messaging timing. Because the server had loaded in first, it tried to synchronize the value. So if we did not have this log here, so if we comment this out, then because the server executed first and it tried to send the synchronization method to the client side, but the client never receives it. So if we press play, we can see that we have two execution methods. We have the server-side execution and we have the client-side execution. But our value updated was never logged because by the time the client actually connected, the server had already attempted to synchronize this value, but the client was not there yet to receive this update. So it's dangerous to have code like this that depends on certain clients to exist. So how can we update this so that it is no longer client dependent? Well, let's go back to utilizing this method, but instead, we'll move this down here. We'll do if we're the client, then we're going to decrement our master volume because the master volume doesn't depend on the server. We want each master volume to be different per client. So my master volume could be different from another client's master volume. And for the server, because it is important and we don't want any client to be able to modify this value and we want to securely manage this value, we want to keep it on the server side. So let's make sure that this value is modified from the server instead. So here we'll do if then we'll do this instead. So if we're the server, then we're going to increment the HP value. So in this way, we are making sure that the client is the only one that updates the master volume, and the server is the only one that touches the HP. So we no longer need this anymore. And let's press play. And we've got an execution from the server and one execution from the client. And here we can see on the server, we have master volume of 100 and we have an HP of 20 because the master volume value is going to be a client managed property. And on the client, we have a master volume of 90 and our HP of 20. So this is exactly what we wanted. We wanted our HP value to be reflected at 20. We want our master volume value to be decremented at 90. So we could of course keep this as is, but it's a little bit messy to look at. So let's actually create two new methods and separate this logic out into its own methods. So first one will have server init, and the second one will have client init. And the server init will make sure that this is server only, and the client init will make sure that this is client only. And in onBeginPlay, for the client, let's decrement our master volume. For the server, let's increment our HP. So we're doing exactly the same thing, but we're simply just going to call server init and client init. Now, why can we do this? This is again because our onBeginPlay is a not used method type. So because we're in the not used execution space, it will be called once for the client and once for the server. Now, when we're executing onBeginPlay for the client, our server init is a server only execution space. And this means that the client cannot call this. So when we're on the client, this line will be ignored. When we're on the server, because the server cannot execute client-only methods, the client init will be ignored. So this will behave in the exact same way that we had before, just a little bit cleaner and delegated out to its own methods. So here on the server side, we've got 120. On the client side, we've got 90 and 20. Next up, let's take a look at executing methods across execution spaces. Now, remember that when we execute methods across different execution spaces, this is going to use up network bandwidth, so this should be used sparingly. And to demonstrate this, let's actually create a text entity, and let's create a world text entity. And let's size this way down. Let's make this maybe 5. That's still a little bit too big. Let's first scale this down a little bit. It's a little bit big. Let's set the text to maybe 2 and font style to maple, and let's set to white. Let's increase the outline color just a little bit. And let's say that our initial text should be ... like we're waiting for some sort of value. So this will be our HP value, and this is going to kind of hover over the player. So now let's create a model out of this. Let's right click and let's create model from entity, and that will give us our model. And let's copy our entry ID. Now here on the client side, let's spawn our HP UI. So let's create another property here. Let's not sync it. And let's set this as an entity type, and we'll name this client HP UI. And in our client init, let's do self.clientHPUI equals, and here let's spawn in that HP text. So we'll do spawn service, and we'll paste in that model. We'll name this entity HP, and let's set the position to vector 3.up times maybe 1. And this will just kind of bump it up just a little bit. This is a local position based on the parent, and the parent will of course be our self. So self.entity. So this is going to spawn our UI in. And let's set our client HPUI's text value to our HP value. So we'll do self.clientHPUI.text render component.text equals toString of self.hp. So this is going to set our text to the HP value. Sorry, I forgot to actually call the method here. So this is a service, this is not a method. So we will actually call the spawn by model ID here. And this will be the method that actually spawns our entity in. So we've got our model ID, the name of our entity, we've got our spawn position and the parent. So let's press play. And there is our health. And if we move around, we can see our health follows us because we've set the health as a child of our player entity. So we've spawned this on the client side. So on the client side, we've got our HP. On the server side, we do not. If we instead, we move this code to the server init, we can see that we have a copy of this on the server as well as on the client. Let's press play again. On the server side, we had incremented our HP value by 10 and our HP value is correctly represented as 20. So we've incremented our HP value and it's at 20 and it's correctly representing our value at 20. The client side is also set to 20, but if we move this to the client and we press play, we can see that our HP value is still at 10, even though our HP value on the client side on our player info component is reflecting 20. Now the reason again for this is because of the timing of the server message being sent to the client side. So the server init and the client init happened at the same time. The server changed our HP value, but by the time we set the text of our HP UI, the client had not yet received this information. So at the time that we set this text, it was still at 10, and then afterwards, it was set to 20. So again, to resolve this, we're going to utilize OnSyncProperty, and we're going to move this part to the OnSyncProperty. And we're going to double check to see if anytime that the name equals HP, then we're going to update this. So every time our HP property is synchronized to the client, then we're going to update our HP value. So now if we press play, we can see that our value now correctly represents 20 because we are only updating it whenever we receive the update message from the server side. Now you might ask, why not just keep this on the server side so that anytime we update the UI, we just update it directly on the server and it will update on the client as well. And the reason for that is because we don't want to overload the server side with entities that don't necessarily need to exist there. UI for the player health doesn't necessarily need to happen on the server. We can keep it on the client side with the server just managing the HP value and not having to manage the actual entities and the manipulation of the entities components. So we only keep this UI on the client and we keep it off the server side. Now we mentioned that we're going to cover sending messages across different execution spaces. So let's actually do that. So let's close out our other methods here and let's create another method called take damage. And we'll keep this as a server method and we'll simply set our HP down by 1. So we're going to reduce our HP by 1 every time we take damage. And we're going to also utilize an event called key down that detects every time we press a key on our keyboard on the client. So this key property will return the key that was pressed, and we're going to do if key equals keyboard key dot, let's say F. Then we're going to call self take damage. Now notice this icon here. Handle key down, as we can see here, is a client-side event. So this is only called on the client side. When we call take damage, we are moving from the client execution space and delegating this execution to the server. So take damage is being handled from the server side, and the client is just making that request to execute take damage on the server. So when we press this key, keyboard key F, we're calling take damage to be executed on the server. It will decrement our HP by 1. Our OnSyncProperty will detect the moment that the server syncs this new change from the server to the client and will update our UI accordingly. So if we press play now, we start with 20 health. If you press F, we can see that our health is slowly decreasing by 1 every time you press F. We can see that our user player info is correctly representing 9 HP, and our client is also correctly representing 9 HP. The last type of execution space that we haven't yet covered is the multicast execution space. And to demonstrate this, first let's set our HP to none so that it's no longer automatically syncing, in which case our OnSyncProperty would no longer be called. So this means that we have to manually sync our HP value. So let's say we took our damage. So we have our key down event and we are taking damage upon pressing the F key. Here we are updating our HP value. So we decrement our HP value by 1, but now we have to synchronize our HP value. So let's say we have another method here and we'll call this sync info. And we'll set this execution space to multicast. Multicast allows this method to act essentially similar to the onBeginPlay methods or some of the other default methods, as if it were the any type. So it'll be called first on the client and then on the server. In our sync info method, we're going to add a parameter for the HP value so that we can manually sync our HP value to the client. So we're going to do self.hp equals HP. And then what we can do is we can update the UI on the client side by doing the client check. So remember, we can do the isClient Boolean check to see if we're executing from the client side or if we're executing from the server side. So if this is the client, then we're going to update the text to the HP value. So we're going to synchronize our HP value to the value that we have on the server. So we're going to update both the server value as well as the client value with the new value. And if it is the client, then we're going to update the UI. So pressing play now, we can see that first off, we don't have the value updated. So we're going to go back into our player info, and in our server init, after we increment our HP value, let's do sync info again, and let's pass in our HP value. And there we have our initial value of 20. We're going to press F to decrement our value, and we can see that our UI is incrementing. Now, why is this important? Because here in our sync info, we can just set this HP up here, and we're already doing so. Well, instead of actually setting our HP, what if we did a data save? So instead of setting this HP value, and we can save this just for the client side, and here for the server, we can do something like save player health data. So we can save our player data for the server, and for the client, we can just synchronize our HP value. So this kind of allows us to have multiple different types of execution depending on whether we want something else to happen on the client and something else to happen on the server. So we can kind of split our behavior this way by utilizing multicast. As a closing thought, I wanted to talk just briefly regarding security. When developing for multiplayer experiences, there will always be bad actors that want to cheat in your game or want to ruin the intended experience for other players. There's no one perfect way to safeguard against this, but there are a few basic concepts to keep in mind as you develop for multiplayer. If you're new to multiplayer development, it's not super important to dive too deep into this quite yet, but it will be necessary as you become more and more serious about multiplayer game development and your game starts to reach a wider and wider audience. Let's begin with the understanding of packets. Put simply, packets are the data that gets passed back and forth between the client and the server. This data can always be manipulated while in transit to the server or client, and unless safeguarded against, can allow bad actors to cheat in your game and manipulate data. A few common ways that these bad actors manipulate data is either by manually triggering remote procedure calls to the server for, say, something like a request reward coin method, for example, that reward them with large amounts of currency or allow them to skip a certain quest without actually doing any of the work. In this case, a common safeguard is to make sure that there isn't a method on the server whose main purpose is just to blindly reward gold to the player. Instead, there should be verification steps on the server that double checks that the right conditions have been met by the right player. Another way that the client can manipulate data is by changing the packet's data values. For example, instead of receiving 1,000 meso from the server, they change the packet so that they receive 100,000 mesos from the server instead. As discussed towards the beginning of the video, firstly, it's important to make sure that critical data is always managed by the server and not the client. Second, in the case of packet modulation, never have a method on the server that blindly takes in parameters from the client and updates values from the server. Ensure that there are verified sources and predetermined amounts that the server rewards so that the client cannot simply request for X number of mesos. And again, the server should always check if the client matches the criteria for receiving the reward prior to rewarding that player. These concepts regarding security were only briefly mentioned to keep you aware of the importance of secure client-server development practices, but for more detailed information and tips, we highly recommend visiting our Creator Center section on security and optimization. And that's everything I have for you today. Multiplayer game development can seem very daunting at first, but hopefully we've been able to demystify just enough of client-server development for you to begin journeying off on your own and making your own multiplayer experiences. We can't wait for your ideas to be a reality on our platform. Happy creating!